Hello again everyone, welcome back to ptet.chemistry channel. My name is Dr. Ont. In this tutorial video, I'll go through this November 2021 paper 2 variant 1 for this Cambridge International O-Level 5070 chemistry curriculum, which is suitable for any 14 to 16 years old IGCSE, GCSE, or in this case O-Level chemistry students. In this first question, we have a list of oxides. To answer the following questions, we just need to use these particular names of the oxides instead of the formula, but there is some usefulness in thinking about the formula of each of these oxides. Aluminium being a group 3 metal, when they combines with oxygen as an oxide, it's going to have metal cations and non-metal anions. When we think about valency, we think about the combining power of the ions based on the charges of the ions. So we just take the number from the charges. These are called the valency or the combining power. When you do the crisscross or the cross multiply, you are doing lowest common multiple, which is your primary school mathematics. How many of those ions are present such that the charges of the cations total will cancel out the charges of the anion total. Plus 3 and plus 3 give you plus 6. Minus 2 times 3 is minus 6. The overall formula is going to be Al2O3 for your aluminium oxide. Calcium oxide on the other hand, Ca2 plus O2 minus. So your valency is going to be 2 and 2. When you do the crisscross, you think about that being how many, but lowest common multiple says that you need the simplest whole number ratio for the ions. So really how many of the ions you actually need to have is basically 1 calcium 2 plus and O2 minus. This happens every single time when the charge of your cations is the same as the charge of the anions, equal and opposite. That means you just need one of each to cancel out the charges of each other. The formula there is going to be 1 calcium 2 plus and 1 O2 minus. So this is going to be calcium oxide like that. Iron 2 oxide contains iron 2 plus as the cations and O2 minus is going to be Fe2 plus and O2 minus. This is going to be similar story, FeO. Same for Mg2 plus being a group 2 metal, Mg2 plus O2 minus. Mg2 plus is just above calcium in the periodic table. Silicon dioxide. So silicon dioxide is under giant covalent structure. Candidates should be able to describe the structure of silicon dioxide as stated in the structure and bonding under giant covalent structure, giant molecular structure. So each silicon is bonded to 4 oxygen because silicon in group 4 they form 1, 2, 3 and 4 covalent bonds. Oxygen in group 6 they form 2 covalent bonds to complete the outer shells, and then the silicon continues outward. This is a giant covalent structure or giant molecular structure. It's a 3-dimensional lattice network. So you will have to break the many strong covalent bonds in order to melt or boil your SiO2. So the formula SiO2, because if you think about silicon and oxygen, these are non-metal and non-metals. We don't talk about ions, but then their combining power depending on how many covalent bonds they need to form in order to complete the outer shell. So you got the 2 and the 4 crisscrossing, but again the lowest common multiple will say that you need to divide by the simplest number in order to get to the simplest whole number ratio. 1 silicon and 2 oxygen, that's going to be SiO2 there. Sodium oxide, this is Na plus and O2 minus. Slowly running out of space here, but Na plus O2 minus, 1 and 2 being your valency. And then when you crisscross, you're going to get how many of these ions? You're going to get 2 Na plus and 1 O2 minus, such that the formula there is Na2O. Last but not least, you get sulfur dioxide, which is an acidic oxide that you get in contact process. The SO2 goes on to form SO3, so there's just sulfur dioxide there. Each of these oxides has certain properties. Al2O3 is certainly a unique one. Together with zinc oxide, this Al2O3 and ZnO, zinc oxide and aluminium oxide, they are what you call amphoteric oxide. They react with both acid and base to form salt and water. So calcium oxide, iron oxide, magnesium oxide, sodium oxide, those are the normal metallic oxides. There will be basic oxide. So these 3 as well as these are what you call basic oxide. SiO2 as well as SO2. So slowly running out of space here to write, isn't it? Let me just write using a different color ink, green color perhaps. SiO2 and SO2. they are what you call acidic oxide. You use SiO2 to react with the basic calcium oxide in the extraction of iron to form slag, which is CaSiO3. It's called slag, SLAG, in the extraction of iron, calcium silicate there. Now, answering these questions, which oxide has a simple molecular structure, also known as simple covalent structure? So a lot of them, they are ionic, it cannot be simple covalent, and then SiO2 is giant covalent between the nonmetal and nonmetals. So really we just have sulfur dioxide. They are not asking for the formula, they're asking you to name from the list. I have just written on the formula to try and go through the relevant points of interest regarding these particular compounds, which of course you should know how to get the formula in the first place. Next question is a colored solid. We are talking about transition metals, or at least compounds of transition metals actually, not the transition metals that are colored, but the compounds of transition metals. Okay, so when they form ions in solutions, when they form compounds, they're going to be colored. So iron 2 oxide is the only transition metal oxide here in this list. So the 2 in the Roman numeral in the bracket refers to Fe2 plus there. Part C contain ions with a 3+ charge. So we're looking at metal oxides, and all of these, the only one which is 3+ is your aluminium oxide, Al3+, group 3 there. So this is your aluminium oxide. And then the next one is a product of thermal decomposition of calcium carbonate. Thermal decomposition means that, you know, it will break in the presence of heat, so they go on to form something else. That means you really need to pump in energy to make it happen, and you will get calcium oxide, and it will also generate carbon dioxide gas. This is part of metals and its compounds, the carbonate kind of chemistry. So we're looking at calcium oxide. And of course, you could also talk about magnesium oxide as well. Okay, magnesium oxide or calcium oxide would have been all right there. So calcium oxide or magnesium oxide. Next up, we have contribution to acid rain. So the only acidic oxide here is SiO2, which is a solid, and SO2 is a gas, sulfur dioxide gas. This is the gas that will go on to form SO3, and the SO3 is the one that will go on to form acid rain. So SO2 there, one of the consequences of releasing sulfur dioxide in a reaction is that it can go on to form acid rain via the SO3 there. So that's it really for this 5 marks first question.